When we talk about individuals, individuals are basically our objects. What are we talking about? So sometimes it'll be people, might be animals. In the homework tonight you'll see we're talking about a lot of different roller coasters. So your individuals are your objects. The objects specifically described by a data set. So you've got your objects, and then we have characteristics of those objects, and we call those variables. Variables are characteristics of an individual. Characteristics of an individual. So our variables, we take them and we divide them into two categories. You have categorical variables and you have quantitative variables. Categorical variables, kind of like it says, places an individual into a category. So I gave you the definition, and here I gave you quantitative. Quantitative deals with numbers, deals with numerical values, which makes sense to find an average. So make sure you pay attention to that. So let me start here. A categorical variable, that might be like gender, or eye color, or what else do we have? Categorical. Marital status. Those are categorical. It's like you're single or you're married, or you're male or you're female. It's a category. Quantitative deals with numbers, so it might be like your age, your income, maybe shoe size. We could find everybody's shoe size in here and find the average of it. What's the average shoe size of my 4th hour stats class? Does it make sense to find an average of zip codes? If we're in 49201 and somebody lives in 49283 in Spring Arbor, does it make sense to find the average of zip codes? No. So I know zip codes are quantitative, but really those would fall into categorical because you don't want to find an average of that. U.S. Census data. Here's information about 10 randomly selected U.S. residents from the 2000 census imported using Fathom software. Again, that's just like a software that people use to analyze statistics and stuff. So who are the individuals in this data set? What is all this information telling us? The individuals in this data set are the 10 randomly selected U.S. residents. What variables are being measured? Identify each as categorical or quantitative, and what units were the quantitative variables measured. So as we look through here, my first one we come to is state. If I have state, this is my first variable, is that categorical or quantitative? Categorical. We have number of family members. And that would be quantitative. You've got age. Age would be quantitative. We talked about this one in the notes. Gender is categorical. Marital status. It's categorical. Total income. Yep. And our last column, travel time to work. How about quantitative? Because again, it's numbers, you can find the average of that. And I skipped out here. It says, what units are the quantitative variables measured? Number of family members. It's like your number of people. Age would be in years. Total income, we have in dollars. And travel time to work, I'm assuming that's in minutes. Makes sense? When it says describe the individual in the first row, you're basically just going to take and write me a sentence. What do we know about this person? This person in the first row. This person lives in Kentucky. They have 2 family members. They're 61 years old. They're female. They're married. Have an income of $21,000, and they take 20 minutes to drive to work. Can we take that and rework it so it's one or two shorter sentences rather than 6 different little sentences? You might say something along these lines. This person is a 61-year-old Kentuckian, 61-year-old female from Kentucky with 2 family members. Was that the right column? Yeah. She is married, makes $21,000 a year, and takes 20 minutes to get to work. So again, all your sentences might look a little different, but as long as you get all that information in there, you'll be good to go. How about on the back? You guys try this one on your own, and then we'll talk in a second here. College majors, here's the distribution of bachelor's degrees awarded in 2007, according to that source. What are the individuals? Yeah, the bachelor's degrees. The people with your bachelor's degrees. And if we just say bachelor's degrees, that would be fine because we're talking about, well, how many business degrees, how many social sciences, how many education degrees. If you missed that question, don't sweat it too much. I'm not a huge fan of this question, but I did throw it in there just to show you how this can work. What are the variables? What are we measuring? Number of majors and percent of majors. Distribution. A distribution tells us what values the variable takes and how often it takes it. Basically, here is a distribution. This is talking about miles of cars and their miles per gallon. What I can do with all this data is I can take and make the very most simple graph you can make. It's called a dot plot. So what happens is you draw your x-axis, and I'm going to tally up how many of these lie at each point. So basically, what's my lowest number? 14. My highest number we go up to, say it again, 33. So if I'm like 14, 16, 18, 20, 22, and I'm going to take and I'm going to plot my mileage per gallon. So I'm going to say this is my MPG to label my axis. And here's what happens. I have 22 miles per gallon here, so I go to 22, and I put a dot at 22. I have 23 here, so I go to 23, I put a dot at 23. I I try to make them relatively the same size and keep them all in the same rows. Here I have 14, so I put a dot at 14. We have 28 and another 28, so I come down to 28, I put a dot, I put a second dot on top of it. We've got 25 and 33. Two 30s. Another 33. And notice how I'm doing the best of my ability to keep this first row lined up, keep your second row of dots lined up. And you can go ahead and finish that, 25, 32. So here's what we did. We took all this information, we made a dot out of it. What we did is we made a distribution of the mileage per gallon for all those cars for that set of data. All right? Let's wrap this up. We look at our data, and we make inferences. What do you do when you infer something? Like draw a conclusion, right? Here's kind of like the overarching idea of statistics. We have a population, we take a small sample from it. So it's like you've got everybody in the United States. Is it realistic to survey every single person in the United States? Not really. So you take a representative sample. So we collect data from a representative sample. We perform data analysis. So that's where you'd go in and either sort your information, make a graph of it, draw conclusions. And once you draw your conclusions, then based on our sample that we took and we did our data analysis with, we will make an inference about the population. Or we'll draw conclusions about the population based on that sample. So you perform your data analysis, and then we make inferences about our entire population based on that sample that we have. That's the introduction to your stats book, to this content. It's really short and really sweet compared to your other lessons. We're going to go like this. Here is your lesson for tonight, 2, 4, 6, 7, and 8 on page 7.